Hello. Previously, I created a video of me making this application. It's basically a copy and paste from the NPM uh, site for Three.js, the Three.js library. And you may be wondering if you would ever have to do this as a developer um, in a professional way. And the answer is surprisingly yes. A lot of times they have these things in Agile called spikes. They're also called proof of concepts in uh, other systems. But basically, the idea is that you have a platform that's fairly complex and you're trying to prove that a technology can be used within your platform. And it can't always be used. So this would be an example of something you'd throw together very quickly so that you can just prove that, hey, we can run Three.js within our platform. So I did that, but at this point, there's a good chance that they'll say, okay, yes, let's proceed, and this is what we want. And it would probably be a good idea if you understand what's going on when that happens. There's a lot of things you can do to get a better understanding of a library. The first thing I normally do is do strong typing. This is an amazing thing that TypeScript provides. And basically, the way I do it is I will purposely put the wrong type in. So in this case, I'll say, hey, this is a camera is a string, and then it'll tell me, nope, it's a perspective camera. To me, the main benefit of this is the copy and paste. So I don't have to sit there and try to figure out how to spell everything. I can just go boom. And now Visual Studio Code will do an analysis of your libraries and see if it finds a version. Sometimes it'll find more than one. So you need to kind of pay attention here. And then you can tell it to import this from 3. So now we have this perspective camera import from 3 up here on line 5, and over here we have this. And so we can mouse over and we can see the comments that they kindly provided. And this says this is a camera that uses perspective projection. This projection mode is designed to mimic the way the human eye sees. So this is probably going to be the best one for us, right? There's probably other schemes out there, but since I'm not really an art major, or I don't really understand photography or anything like that, this one that mimics the human eye sounds like a good thing for me. I can also go to the definition, and within the definition, I can see that these are all. Let me slide this over. Um, so these are all. This is the first one's for something called FOV, and it is defaults to 50. Aspect has a default of 1. So all these things, near has a 0.1 and far has a default of 2000. So I think what this is saying, at least for these last two, is that anything that is closer than 0.1 to the camera won't be calculated. The math for that won't be calculated. And anything that's farther than 2000 from the camera won't be calculated unless you set something. So let's go back and look at our example, close others, and we will see that we set it to zero point 0.1, which is the default, and 10, which is probably why this is getting cut off. It probably should be 20 or something like that. Because when we put our camera, we put it at 10. So any of these pieces, these edges here that go beyond 10 won't be calculated, won't be displayed. So we could move it closer and then we wouldn't have that problem. So let's see if we make this 5. You notice now nothing gets cut off. I made it 3. So we'll go 5. Nothing gets cut off. So that's pretty nice. So I'm just going to leave it like that. And we're going to go with this perspective camera. I apologize. My dogs are barking. I think Amazon just dropped something off. But let's move on and let's see what happens when we set scene to a string. When we say, hey, transpiler, we have a string here. And it says, no, you don't. You have a scene. So I say scene, paste this here, and then I say import from 3. Now I'm telling you, in a like a professional environment, you will probably have tons of libraries and you will have overlap in these things. So you kind of have to pay attention at that point. So anyways, we save it. Looks good again. We hit scene, and this allows you to set up what and where is to be rendered by Three.js. That makes sense. That's what seems to do. It does seem to me like just the way my brain thinks that I should create a scene and then create a camera, but I guess it doesn't matter because the order is not doesn't make a difference. So now we're going to call this box geometry constructor, and I'm going to say that it's a string. That's pretty cool. It's actually a box geometry, which makes a lot of sense. I love it when they're consistent like that. And we will paste that, and then I'll do an import from 3, save, and let's just read it. This is a geometry class for a rectangular cuboid with a given width, height, and depth. So we can go in here, and we can see that we have these things in these arguments in the constructor, and they're all optional because we have these question marks here, and additionally it does say that they are optional up here in this requirement, and that they default to 1 1 1, and then we also have something which I don't think we're using called width segments, and it's the number of segments the rectangular faces along the width of the side, and it defaults to 1. So basically it's going to have one segment per side, it looks like. So that makes sense. Okay, so we'll come back over here and just validate that so we create a box geometry of 2 2 2. So let's go ahead, since we made it bigger, we made the camera closer, we're just going to make it 1 1 1, so we're back to the original. And we still aren't seeing anything getting cut off, so that's all good. So now let's go to material. Let's see. So I'm going to go straight. I'm trying to talk loud because it's so quiet, and I tried to use Windows ClipCut, and it's trying to do it in the cloud, and it's super slow. So now I'm redoing this, and I'm trying to talk really loud. I apologize if it's super quiet for you. So now we have a mesh normal material. That's cool. We hit paste this in here and save it. And it's upset. Oh yeah, because we didn't import it. We import it. Now mesh normal material, doesn't give us any information, and I'll show you why. So we go in here and see the other ones had comments up here, and this one does not, which is a bummer. And then it has a constructor which takes one thing in, and it's just something called parameters, which are mesh normal material parameters. So we could go in there, go to definition, and we see that the parameters are fairly complex. They have a bump map, bump scale, so a bunch of stuff that I don't really understand. It's definitely something that materials are probably something that we'll have to come back and understand better in the future. We definitely need to sort of note that in our head that we have a blind spot there, and hopefully some opportunities to learn about these materials present themselves in the future. But let's move on. And now we have a mesh. Okay, so we are going to pass our geometry, which we got up here, and our material to this constructor called mesh. And this will return I'm guessing a mesh object. Let's see. Yep, a mesh object, and it has a box geometry, which makes sense. We created a box geometry that makes sense, and a mesh normal material. So this will only take a mesh normal material. But then there's this third thing called an object 3D event map, and that makes not a bit of sense. So let's go ahead and copy this over. And there we go. We've copied it, and now I'm going to import our mesh. And we are going to import that from 3. And then let's go ahead and go over there and sort of if we can get some clues, especially about this T event map thing. See, it's a So in the constructor itself, it only takes two things. So I am, it's not clear to me what this is about. Again, another blind spot, something we need to keep in mind if we progress further in this project. If they were to say yes, let's go for it, we need to be clear that we don't really understand this piece. So now let's go ahead and bring that in, this mysterious object event map thing. I think we already went there, but let's go ahead and go again. Object, this is a base class for most objects in Three.js and provides a set of properties and methods for manipulating objects in 3D space. So it's an event map. I think that naming is a bit confusing. It probably isn't if you actually know what it is, but it is definitely fairly mysterious at this point. Um, and that is something you just have to learn to live with as a software developer. You're not going to understand everything all the time. Eventually, if you do sort of in your mind go, hey, there's this thing, it's an object 3D event map, and then one day you may be watching a video on YouTube or something and they talk about it and you'll be like, oh my gosh, I need to pay attention to this. So I kind of try to, like, in my day to day, whenever I run across anything like this, I try to note it and sort of make a big deal in my head about it so that when an opportunity to learn about it presents itself, I'm ready to roll. So all we have left, I believe, is this renderer thing. So this is a new WebGL renderer. So we'll do our thing. We'll call it a string. The dogs are very excited again. And here we go. And it is a WebGL renderer. So they've stayed very consistent. They name the object types the same as the class names, which makes a lot of sense. I guess that is what it would be. So because we're running a class, the constructor of a class WebGL render, so it's going to return the class. And then we are going to import that from 3 and then save that. We're good. Let's go ahead and mouse over it. WebGL render displays your beautifully crafted screens using WebGL if your device supports it. This render has way better performance than Canvas render, and that makes sense. I believe if you have a graphics card, it will leverage that. WebGL renderer will, but Canvas will not. And a graphics card is designed to handle these sorts of calculations. So it's going to be a lot faster. Um, and the only thing we passed it is a single object that says anti-alias is true. I wonder if we change this to false, if anything interesting happens. Oh yeah, you can kind of see the little spikes and stuff over there. Yeah, it's definitely cleaner and smoother with the anti-aliasing on. Very cool. Anyways, I hope I talked loud enough, and happy coding, everybody. Bye-bye.